The first time I bit into a Ferrero Rocher, I was transported back to my first factory tour as a teenager. Both experiences revealing unexpected complexity beneath a simple exterior. That perfect layered effect, from crunchy hazelnut center to wafer shell and chocolate coating, ignited my engineer's curiosity. How could something so delicious also be a marvel of manufacturing precision? After months of research and reaching out to industry contacts, I finally got answers about their production methods. What makes these golden spheres so special? The manufacturing rivals automotive assembly lines, with specialized equipment operating with millimeter tolerances. Ever wondered why these chocolates command premium prices? The engineering complexity I'm about to show you explains everything, and might forever change how you see these treats. Ever wondered why a Ferrero Rocher tastes the same whether you buy it in New York, Tokyo, or anywhere else in the world? That consistency isn't a happy accident. It's the result of an ingredient selection process so meticulous it would make even luxury car manufacturers nod in approval. Unlike most chocolate companies that simply buy their ingredients from suppliers who meet basic quality standards, Ferrero takes a radically different approach. They've essentially created a vertical integration system that would make Henry Ford proud. The foundation of this system: complete control over their most crucial ingredient, hazelnuts. Ferrero stands as one of the world's largest hazelnut producers, owning extensive orchards across Turkey, Italy, and Chile. This strategic ownership maintains absolute control over quality and ensures a consistent supply regardless of regional weather patterns or growing conditions that might affect any single location. Each harvested hazelnut passes through a selection process that parallels quality control systems used in Formula One racing components. High-speed optical sorting machines scan individual nuts, rejecting any with imperfections in color, shape, or size. Much like how race car manufacturers inspect critical parts where a single flaw could mean catastrophic failure during a race. Moving beyond hazelnuts, Ferrero's chocolate formulation follows equally exacting parameters. Their engineers maintain a specific ratio of cocoa butter to cocoa solids that creates the perfect melting point. Too soft and the chocolate becomes messy and unstable. Too firm and it doesn't release flavors properly when eaten. Then comes the engineering challenge of the wafer shell. Standard wafers typically become soggy when in contact with moist ingredients like chocolate cream. Addressing this issue, Ferrero developed a specialized wafer formula with a unique moisture barrier, comparable to how automotive engineers develop protective coatings that shield critical engine components from heat and corrosion. Before entering production, each ingredient passes through Ferrero's dedicated testing laboratories. Here, technicians analyze over 30 different quality parameters using equipment similar to what you'd find in advanced automotive testing facilities. For hazelnuts alone, they examine everything from moisture content and oil profile to shell to kernel ratio and flavor compounds, utilizing spectrometers, chromatographs, and other analytical instruments that measure components at the molecular level. This fanatical approach to ingredients comes with higher production costs per unit compared to competitors using commodity ingredients. But this investment pays off in brand loyalty and premium pricing. When you pay more for a Ferrero Rocher, you're not just buying fancy packaging, you're buying the certainty of a consistent experience. Quality control extends throughout the entire supply chain. Temperature-controlled shipping ensures ingredients and finished products maintain optimal conditions, similar to how exotic car manufacturers transport their most sensitive components from factory to assembly line. Even sugar receives special treatment at Ferrero. Their proprietary crystallization process creates sugar crystals of precisely controlled size, affecting not just sweetness, but also texture and mouthfeel. This meticulous attention to what most companies consider a basic commodity creates that signature Ferrero Rocher experience that chocolate lovers worldwide have come to expect. While that signature Ferrero Rocher experience begins with quality ingredients, the true manufacturing marvel happens at the heart of each chocolate, that perfectly centered whole hazelnut. This seemingly simple feature requires manufacturing precision that would impress aerospace engineers. Hazelnuts present a unique manufacturing challenge. Unlike manufactured parts with uniform dimensions, these natural ingredients vary wildly in shape, size, and density. Creating consistent products from inconsistent ingredients requires extraordinary engineering solutions, similar to how master mechanics must tune engines to peak performance despite variations in fuel quality and environmental conditions. The journey to the center of a Ferrero Rocher begins in massive roasting drums that look more like equipment you'd find in an industrial foundry than a chocolate factory. These precision-controlled rotating chambers roast hazelnuts at temperatures carefully calibrated to within 2 degrees Celsius, too hot, and the nuts develop bitter compounds. Too cool, and they retain moisture that would later compromise texture. What's fascinating is how similar this process is to heat treating metal components in automotive manufacturing. The rotating action ensures even heat distribution, while computer-controlled temperature zones develop specific flavor compounds that form the foundation of Ferrero Rocher's distinctive taste. After roasting, the hazelnuts face their first major test. Custom-designed optical sorting machines inspect each nut at remarkable speeds. These systems use high-resolution cameras and artificial intelligence to evaluate hazelnuts based on incredibly strict parameters, with size tolerances of just 0.2 millimeters, about twice the thickness of a human hair. I've worked here for 15 years, shares one quality technician, and I still feel pride watching these natural ingredients transform into such precise components. Nature creates the hazelnuts, but we perfect them. Any hazelnuts that don't meet the exact specifications are automatically rejected. It's a ruthless selection process that ensures dimensional consistency across millions of chocolates. When was the last time you bit into a Ferrero Rocher and found an unusually small or large hazelnut at the center? Probably never. The carefully sorted hazelnuts then move to one of the most impressive stages of production: robotic placement systems. Working at speeds of up to 500 units per minute, individually position each hazelnut with microscopic precision. These systems, which borrow technology from high-speed electronics assembly, ensure each nut is perfectly centered before the next manufacturing step begins. Each positioned hazelnut receives a preliminary chocolate coating through a specialized enrobing process. This foundation layer serves critical functional purposes, creating a perfectly smooth surface for the subsequent wafer layer and forming a moisture barrier that preserves the hazelnut's crunch. Temperature control during this coating process is absolutely critical. The chocolate must be maintained within a narrow 1.5 degrees Celsius window throughout application and cooling. Too warm, and the chocolate won't properly crystallize. Too cool, and it becomes too thick to form an even coating. This temperature precision ensures that the cocoa butter forms the correct crystal structure, specifically the form known as beta V crystals. Only these crystals create the perfect snap when you bite into the chocolate, while also giving it that characteristic glossy appearance. The technology behind this process bears striking similarities to precision cooling systems used in manufacturing engine components, where temperature control directly affects material properties and performance. In chocolate making, as in engine manufacturing, even a few degrees of variation can mean the difference between success and failure. What makes this engineering particularly impressive is the scale and speed of production. A typical Ferrero production line processes hundreds of thousands of chocolates daily, with each hazelnut receiving this same meticulous treatment. The combination of volume and precision puts these production systems in the same league as the most sophisticated automotive assembly operations. That perfectly engineered hazelnut center is just the foundation for what might be Ferrero's most impressive manufacturing feat. When you bite into a Ferrero Rocher, have you noticed how the wafer shell shatters with exactly the right amount of resistance? That distinctive crunch is the result of manufacturing technology that competitors deemed impossible to create at industrial scale. How does Ferrero create those perfectly spherical, crisp wafer shells when most confectioners stick with flat wafer sheets? The challenge stumped engineers for years, creating curved, hollow wafer spheres that maintain consistent crispness while surrounded by chocolate seemed impossible to scale. The solution required an entirely new manufacturing approach that revolutionized candy production. The process begins with Ferrero's proprietary wafer batter mixed to exacting specifications. Unlike typical wafers, their formula contains specialized ingredients, allowing it to form complex shapes without cracking. This batter flows into custom-built ovens where temperature control systems maintain heat within a half-degree tolerance, precision that exceeds standard industrial ovens. As the batter bakes, specialized molds create wafer sheets with a consistent thickness of just 1 millimeter. Even a tiny 0.1 millimeter variation would create weak points that ruin the final product's signature crunch. These golden sheets then enter conditioning chambers where humidity levels are precisely regulated. Too dry and the wafers crack when formed, too moist and they'll become soggy when filled with cream. This conditioning process adjusts moisture content to within 2% of target, creating perfect material properties. The conditioned wafers move to Ferrero's proprietary forming stations, where heated dies press the flat sheets into perfect hemispheres. This technology shares DNA with automotive panel stamping, but with a crucial difference. Wafers are far more delicate than steel, requiring requiring gentler pressure and more precise temperature control. The forming process is where most competitors gave up, explains a former Ferrero production engineer. Creating spherical wafers that maintain consistent thickness around curves without developing stress fractures seemed impossible at industrial speeds. We had to invent entirely new machinery to solve it. Once formed, half of these hemispheres receive a precise deposit of chocolate hazelnut cream measured to within 0.05 grams. This cream layer delivers flavor while creating a moisture barrier that keeps the wafer crisp despite being surrounded by chocolate. Robotic placement systems position each pre-coated hazelnut exactly in the center. Any misalignment would create an unbalanced product with inconsistent bite characteristics. The most delicate step follows, joining the two hemispheres. A thin ring of tempered chocolate applied to one hemisphere's edge acts as an adhesive when the second half is placed on top. This chocolate weld must be strong enough to prevent separation during handling, but thin enough to maintain the perfect crunch when bitten. The joined spheres pass through a cooling tunnel where the chocolate seal solidifies in seconds. High-speed cameras inspect each sphere for proper alignment and seal integrity, automatically rejecting any that don't meet Ferrero's standards. These rejected pieces never reach consumers but are recycled back into the production process. What makes this engineering marvel particularly impressive is that all these precision steps happen at speeds exceeding 300 units per minute on a single production line. The combination of speed, precision, and delicacy puts these wafer forming systems in the same category as some of the most sophisticated manufacturing equipment in any industry, all dedicated to creating that perfect crunch when you bite into a Ferrero Rocher. While forming perfect wafer spheres might seem impressive, the next stage is where Ferrero Rocher truly transforms into that iconic chocolate we all recognize. The outer coating is engineered with millimeter precision using technology borrowed from automotive manufacturing that most food companies haven't even considered. Each chocolate-encased wafer sphere enters an enrobing system, essentially the chocolate equivalent of a car wash. These spheres pass through what engineers call a waterfall curtain of liquid chocolate. This curtain creates an unbroken cascade that surrounds each piece with exactly 2.5 millimeters of chocolate. Think of it as the precision coating on a luxury car part, where microns matter. This specific thickness balances structural integrity with optimal taste experience. Temperature control here is absolutely critical. The chocolate mixture stays at exactly 31 degrees Celsius throughout the enrobing process. 1 degree hotter, the chocolate won't properly crystallize. 1 degree cooler, it thickens too quickly, creating uneven coverage. As one chocolate engineer explained, temperature precision is why both Ferraris and Ferrero chocolates have that perfect finish. What happens next takes the process to another level. While the chocolate coating remains tacky, the candies enter a specialized chamber for applying those distinctive crushed hazelnut pieces. Ferrero employs an electrostatic application system, similar to what luxury automakers use for their automotive paint application. The crushed hazelnuts receive a slight electrical charge as they're propelled toward the chocolate-coated spheres. The chocolate surface carries the opposite charge, creating an attraction that distributes nut pieces evenly across the entire surface. Without this technology, the hazelnuts would clump in certain areas, leaving bare patches on others. This electrostatic application guarantees that perfect ratio of chocolate to hazelnut in every bite. The newly coated chocolates then move through a controlled crystallization tunnel, a sophisticated cooling system with multiple temperature zones. This isn't just about hardening the chocolate, it controls exactly how and when different parts of the coating solidify. The first zone gradually reduces temperature to initiate crystallization. Later zones carefully manage the cooling rate to prevent chocolate bloom, that whitish discoloration that appears when chocolate is improperly tempered. The entire cooling process follows a precise temperature curve, dropping from 31 degrees Celsius to room temperature over a carefully calculated time period. Quality control stations along this tunnel use high-speed thermal imaging cameras to monitor each chocolate's surface temperature. Any piece showing abnormal thermal patterns, indicating potential gaps in coverage or improper crystallization, that gets automatically rejected by precision air jets. These jets blow defective pieces into a recycling bin without disrupting production flow. For chocolates that pass inspection, this precise coating creates more than appealing aesthetics. The exact thickness provides crucial protection for the delicate wafer beneath. It creates a moisture barrier, extending shelf life while remaining thin enough to deliver that satisfying crack when bitten. The evenly distributed hazelnut pieces add texture contrast, making each bite more interesting than simple smooth chocolate. All this happens at remarkable speeds, up to to 500 chocolates per minute on a single production line. The combination of precision, speed, and quality control in this coating process represents manufacturing engineering that rivals systems costing millions of dollars in other industries. 500 chocolates per minute might sound impressive, but what happens when these delicate spheres need to survive shipping across continents without a single crack? The final step transforms these engineering marvels into the iconic gold-wrapped treats we recognize, using packaging technology that's just as sophisticated as what's inside. The gold wrapper that's become synonymous with Ferrero Rocher isn't just about looking fancy in the candy aisle, it's the result of careful engineering designed to protect a surprisingly fragile product. Think about it, you've got layers of delicate wafer, temperature-sensitive chocolate, and crunchy hazelnuts that could easily become damaged during transport. The wrapping process begins with specially designed aluminum foil that's thinner than a human hair, yet strong enough to maintain its shape. This isn't your kitchen aluminum foil, it's a specialized material manufactured to food-grade specifications with precise thickness consistency. The inside surface features a proprietary non-stick coating that performs two critical functions, preventing the foil from adhering to the chocolate surface and creating an additional moisture barrier that extends shelf life. High-speed wrapping machines fold this foil around each chocolate sphere using a mechanical process that creates those signature pleats we all recognize. These machines operate with tolerances measured in fractions of a millimeter, ensuring the wrapper conforms perfectly to the spherical shape without damaging the delicate chocolate coating. The pleating pattern isn't random either. It's engineered to provide structural support that helps protect the chocolate during shipping and handling. Once wrapped in gold, each chocolate moves to the next station where it's placed into those distinctive fluted paper cups. These aren't just decorative. The fluted design creates air pockets that act as mini shock absorbers, providing protection against impacts during shipping. The placement itself is handled by precision robots that can position up to 400 chocolates per minute with perfect centering. What's particularly impressive is that none of this packaging can be tested on the actual product before production. Engineers must design systems that handle the chocolates with just enough pressure to secure them without causing damage. It's similar to how automotive assembly robots are programmed to handle delicate components with precise force control. Before multiple Ferrero Rocher candies are grouped into their transparent plastic containers, each individually wrapped chocolate passes through a gauntlet of quality inspections. High-resolution cameras capture multiple angles of each chocolate, analyzing the wrapper pleats, overall symmetry, and surface appearance. Meanwhile, sensitive weight sensors verify that each piece contains the correct amount of ingredients down to the 10th of a gram. The inspection technology can identify defects invisible to the human eye. A slight tear in the foil, an imperfect pleat, or even a chocolate that's 0.3 millimeters out of round. For perspective, that's about 3 times thinner than a credit card. Specialized software processes these images in milliseconds, triggering rejection mechanisms that remove substandard pieces without interrupting the production flow. The final step involves grouping the wrapped chocolates into their familiar transparent containers. These aren't ordinary plastic boxes, they're made from a specialized polymer that maintains clarity while providing protection against moisture, temperature fluctuations, and UV light that could degrade the product. The distinctive shape of these containers isn't just for brand recognition, it's designed to distribute impact forces away from the chocolates inside. Even the snap-fit lid is engineered to create an airtight seal that preserves freshness while remaining easy for consumers to open. The entire package undergoes rigorous testing to ensure it can withstand everything from being tossed in a shopping bag to being shipped thousands of miles in varying temperatures. The attention to detail in Ferrero Rocher's packaging mirrors the precision found in their manufacturing process. Every aspect serves both functional and aesthetic purposes, protecting the product while creating that premium unboxing experience that makes receiving a Ferrero Rocher gift so satisfying. So there you have it. Behind every Ferrero Rocher lies an engineering marvel that many automotive factories would envy. What's truly remarkable isn't just the technology, but how seamlessly Ferrero blends chocolate-making craftsmanship with precision engineering, like a Swiss watch factory dedicated to creating moments of indulgence. This perfect marriage of tradition and innovation creates that signature experience, the satisfying crack of the shell giving way to layers of flavor and texture, culminating in the hidden hazelnut treasure. Next time you unwrap that golden sphere, remember the symphony of engineering that made it possible. If this journey behind the chocolate curtain fascinated you, hit subscribe for more videos revealing the hidden wonders of everyday products we take for granted.